Hi, in this video we will discuss about gradients of a straight line and what problems according to that. Yeah. Okay, now are having right angle triangle, and you know that this is 90-degree angle, and we have to find out the gradient for this. Yeah, and you know that what's the gradient y over 2. Yeah. And that would be equal to 2. 2 is the slope, or you may say the gradient of this whole thing, y over x values. So let's check out another question. And over here they have given us the order pair, and now we have to take out the gradient from these points. A has this point and B has this point. So what's the formula of taking out the gradient? That's y2 minus y1, x2 minus x1. Okay, so it's the line A and B, and we have to write the y values. This is y, let's say it's x1 and y1, and this outer pair is x2 and y2. Yeah, that's right. And now we have to do this thing. You can see that I have put y2 first, and then the subtraction with that, and 4 minus, again we have to do, yeah, and that will be equal to 1 plus 1 and 4 plus 4, 2 over 8, and that would be 1 over 4. So that's the gradient of this whole A to B line, and the points are given in order here. So let's check out what problem related to the gradient. After takeoff, an aeroplane climbs in a straight line with this gradient. Yeah. When it has reached the height of 2000 meter, how far it has gone? Has it gone horizontally? So we have to find out the x value. You know that we have gradient this, y this, and we have to take out the x value. Just putting the y value and move our x to the other side, and moving 5 to the right side. So that would be 10,000. All right, so the x value, or you may say that how far has it gone horizontally? It has gone 10,000 meters square, meter, not square. All right, now again we have to check out another word problem related to gradient. The roof of this garden shed has a gradient. Yep, this whole thing has gradient 0.35. Find the height of the shed. All right, we have to find out the height. Okay, this whole height, we have given this much height, this much horizontal distance, and the gradient as well. So, but we need to find out this whole height of that chart. All right, we have the slope, that is this. Y2 is given, y1 is given. Why do we need to find? Y1 is given, and x value. Yeah. Let it write it as x 0.35, y2, that is your height. Just write it as 8 and 1.8 over here, and x value would be 1.5. So I think so you can do it. 0.35 times with, you just need to change the position whenever you move towards the other side, and then h minus 1.8, and again we have to move. You can do it all calculation by using calculator. I'm not doing the calculation, but you can get the answer by putting these values on your calculator. Yeah. Again, we have a seat. The seats of a football stadium are on a slope. Okay, this is the slope, with gradient 1.2. Just like write it as m equals to 1 by 2. What's the height of each? What's the each height of the bottom seed cell? You can see that y2 is given, y1 is unknown, and we have the x value. So we can easily write it y2 minus y1, and over here is the x value. The rest is yours. So let's check out another problem. We are moving towards more and more complex problems related to the gradient, or you may say the slope. The road has a gradient 1.5, 1 over 15 for first 90 meter. So this hole has a gradient 1 over 15, or you may write it m1 as this. We are given with x value. Then there is horizontal, and you can write m2 will be equal to 0, x is equal to 130 meter, and obviously y will be that much height that is given over here. Okay, whatever you find out after doing this whole calculation, that would be the value of y over here. Yeah, and the last one is you have given the 200 meter, m3 is given 1 over 25, x value is given 200 meters, and y we need to find it out. Okay, all right, so they want to find the total height gain from start to finish. We have to do this calculation, and then we will find out the total height and the average gradient. That's we need to find out. All right, so what will be the height? 1 y over x, yeah. 1 over 15 y over 90. So just move 90 over there, and we got 6. So we have 6 meters over here too, and you know that it has crossed 6-meter height. This is total 6-meter height that it has gained. All right, now we have to do this part. 1 over 25 y over 200. Yeah, 200 over 25, that would be y is equal to 8. Yeah, so 8 meters. And now we have to calculate the total height. And the total height, this much equals to 6 meter, and this much equal to 8 meters. So 8 plus 6, that would be equal to 14 meters. So 14 meters is the total height that he has gained from start to finish. So what will be the gradient, average gradient? You know that 1 over 15 plus 0 plus 1 over 25. So the average gradient will be equal to this 1 over 15 plus 0 plus 25, 1 over 25, and after doing this whole we will get 8 over 75, and when we divide this whole thing by 3, because we are taking the average gradient, we'll get approximately 1 over 30. Yeah, that's the average gradient. That's all a mess. Messy. Okay, now the mast of a Millennium Dome were held up during a construction by wire ropes as shown in the diagram. A is 106 meter above the sea, is vertically below. The gradient of AB is 1. C is given 53. Yeah. So what do we need to find? The gradient of AD. All right, yeah. And the length of BD. First of all, we can easily find out the BC and then total up with this. All right, let's check out gradient of AD. we have the 106 and 53, y and x is given. You can easily find out 106 over 53, and that's equal to 2. And you know that A is above, so you can see that C is below. That is already mentioned over here. C is vertically below, so all the other points B and D will also be in the lower side, on the lower side. So you can say that the gradient must be descending gradient, and that will be equal to -2. Okay, and what do we need to do? The ADs, we have already found out the AD, and now we have to find out the BD value. We have the slope of that area, this whole area. Let me write it over here. 106, the slope is given. We have to find the BC value, and here is 106. X is given. Yeah, X is equal to 106 meters. Alright, so this will be also equal to 106. And now we have the 53 length. 106 is given. We have to total this all up, and we will find out the value of BD. 106 add up with 53. What's that? 106, 53, 9, 5. Yeah, 159. So 159 is the total length of BD. It's quite simple. All right. Let's check out this one. A crane is lifting a board suspended by wire ropes AB, AB, and AD. A point C is vertically below BC. This hole is 5 meters. The gradient of AB is given already, and that's equal to 0.8. How high is, so the gradient is given, but we need to find the length and how high is the A above C. We have to find out this length. AD gradient is also given, and you can see that it's in negative, so it's a descending gradient. Yeah, it's in positive. And sorry, I just mistakenly write this hole as BD length as 5 meter, but it's BC length as from start. This starts from here, ends up here, 5 meters. So we have to find out this one and calculate this hole to take out the value of length of board. Yeah. So after, first of all, we can easily find out the height by using this slope and this length. So slope is given 0.8, just write it as m1, and that's equal to AC over BC. AC isn't given, but BC is given, and 0.8 times with 5, 0.8 times with 5, that will be equal to 4. AC is equal to, so the first part is done. How high is A above C? That is 4 meters. Alright, so now you have the length, you have the slope over here, but you can easily find out the CD value from. So that way you can easily write M2 equals to negative 1.25, and if you can just miss that negative, that's also fine. For our X, we just need to change the arrangement. For our 1.25 X, I'm just using this thing. We need to find out the X value. So that's equal to 3. And that's value equals to 3.2. And it's my unit in meters. Alright, so now we have to add up 3.2 into 5. And that's equal to 8.2. Yeah. 3.2 adds up into 8.2 meters, and that's the total length of the boat. So in this video, we have discussed a lot of examples related to the gradient. Yeah, I hope you understand it.